Oh, welcome back to this random tool where I fix stuff. Today we have a Radiola 60 chassis, power supply part here, and the receiver part here. This actually is supposed to go on this side. You can see all the wires over here that connect to this terminal strip here. Anyway, this is a superheterodyne radio from 1928. I just got the chassis, I don't have the cabinet. We're going to see if we can get this to work. I have a couple ideas what I want to do with this. These early radios, a lot of them used a high impedance speaker in which the cone only moves like a tiny bit. It's not like a later style voice coil speaker that has the the output transformer and the low impedance voice coil. These are much different style of speaker. Anyway, so that's what this is set up for. The speaker plugs in here. But what I'm thinking about doing is perhaps stealing a speaker from like a Radiola 66 or something like that. That's a dynamic speaker. That has a field coil and everything, and maybe I'll see if I can get that to work with this or something, but we'll see. For now, we're going to start out by doing some continuity checks just to see the status of all the coils in here. There's quite a few coils in here. Power transformer, I think there's 2 filter chokes and then an output choke here. And then we've got at least 1 interstage transformer in here, so I want to do continuity checks on all those and make sure that they're all good. And if they are, we can continue from there and see if we can get this thing to play. So I'm going to flip this thing up. This is power supply here. So I think it's pretty nice under here though. You can see all the wires retain their original colors. Usually these things fade out all to some kind of color in between beige and light green, but these ones still have pretty much all their colors. You can see that one's purple and we got a pink one looks like, so should be much easier to follow the schematic that way. All these wires have the colors. Flip this one up. You can see these old radios didn't have a very high number of components in them. You only got a couple resistors in here, and I think there's only 1 capacitor in here. Oh, there's another one there. So there's 2 big capacitors and a couple of these, super low value ones. These would be like, picofarads or something, and these would be like maybe half or, well, not even half. They probably might be like, 0.1 or something. These big wax ones. This one, I think the larger box is the power transformer, so that would be these 2 holes here, and then the slightly smaller box is the filter choke, so I think there's 2 coils in that, and this box I believe contains the filter capacitors, which are all paper in this. They didn't have electrolytic capacitors at this time, and the output choke would also be in here. So we'll pull up the schematic and see what continuity checks we can do. I have it right here. We got the schematic here. This is the power supply section, and this is that terminal strip, and this is the receiver section over here. So all these coils, like this is an RF coupling. This is the mixer tube. So these are IF stages. So these 3 will be IF coils. You can see those are the 3 right there in the cans. This down here got an oscillator coil. And then over here we've got that interstage transformer. So this is the one that's in the box on top of the chassis. And over here we have the main power transformer here, which provides 2 separate filament voltages. This radio uses mostly 27 tubes with a 71A output. So the 27 tubes need 2.25 volts, and the 71A output needs 5 volts. So you got 2 separate filament windings there. Got the filament winding for the rectifier too. That's going to be 5 volts, and then the secondary B plus winding. There's the rectifier there. And we've got 2 filter chokes and then 1 output choke. And then all these capacitors, 2 microfarad, 2 microfarad. All these ones over here will be in that can with the output choke. You can see there's the speaker terminals there. So let's get to checking these continuities. Okay, so as you can see, I got my real soldering iron out there. I was just really tired of waiting for my little modern one to heat up some of these old solder joints, so I got out this guy, which is a very nice thing to have. Didn't have to do much soldering. I checked out all the coils that I could, and they all checked out good. The only ones that I couldn't check out are the neutralizing windings on the IF transformers because they're internally connected to a trimmer capacitor, so there's no way to get at those the ends of that coil unless you take the can apart, which I'm not doing. But everything else checked out good. Volume control checks out good. Those like to go open sometimes. That's just a big wire wound pot. The only issue that I found was this resistor, which on the schematic was supposed to be 20k ohms. When I measured it, was measuring about 6k ohms, so I replaced that with a new 3 watt 20k ohm. I doubt that this thing was 3 watts. Usually the older resistors are very large for their power rating. This big guy right here might only be like a quarter watt or something, so I'm pretty sure this 3 watt one will be sufficient in here. Everything else I think checks out good, so you should be able to power this up. And I'm going to move this over there because the connections are on that side, and I'm going to power it up without the speaker connected, and I'm going to check the B plus and also check and make sure that there's no DC voltage on these speaker terminals. There shouldn't be because there's a capacitor in series with this, but just in case the capacitor is leaky or shorted or something, we can check that just so I don't blow up my speaker. And if those two checks pass, if the B plus looks good and there's no DC here, we'll plug the speaker in and see if this thing will play. There's another thing I forgot to mention. The plug was kind of smashed, so I tried to glue it back together as best I could with the pieces I had. It's probably not going to stay like this. I'll probably have to find a replacement plug because there's quite a few pieces missing, like this piece right here. So if you grab it like that, you're going to be touching the contact right there. So I'll probably have to get a new plug, but for testing today, this should be sufficient, I think. Alright, so I got all the connections hooked up. I verified that the connections are correct. These last two are a little hard to tell because the wiring color looks pretty much the same, but this one looks a little bit more red than that one, so should be alright. We'll power this up. I've got it plugged in and turned on. I just don't have my extension cord plugged in, so we'll plug that in and it should come on, hopefully. I've got my meter hooked up to the B+, should have that on DC actually, and we'll see what happens. I plug this in. Right, pilot light came on, so that's a good sign. See if we can see any tubes. Rectifier tube is lighting. It's like we've got 216. Will probably come down once these tubes start conducting. If they do, because I don't actually see them lighting. The 71A is lit. But none of these tubes is going to be lighting as far as I can tell. Okay, let's check the AC voltage on here. This last two is AC. Have 2.9 volts, so they should be. Not seeing any illumination. These tubes usually do take some time to go off, but I should be seeing something going on. I'm not seeing anything at all. I wonder if there's a break somewhere in that wire. That's to 2.9 volts AC. That definitely should be lighting, but I do not see anything. I have to probe the tube socket directly. See if there's any voltage in there. Should have 2.5 or 2.25 volts on these tubes. And we have nothing. Okay, so maybe there's a break in one of these wires. Looking at them now, they actually don't look so hot. So let me unplug this. It's not really a good idea to run this without the load over here. Even in the manual they say never run it without this attached because the voltage without this load on goes much higher than the capacitors or anything in this was designed for. So you're not supposed to run this without this attached, and without these tubes lighting is basically the same thing of running this without this attached. So let's see if we can figure out why we have no continuity, why we have no power going to these tube filaments. Turn the lights back on. So that's these last two terminals here is the 2.5 volt or 2.25 volt supply for the type 27 tubes. I'll take these out. And now these do seem to be a little messed up here. Actually, everything looks a little messed up there. Okay. So let's check continuity. Go to resistance. And we can check continuity between that wire and one of these. It's coming up 0.8 ohms. It's coming up ohms. I think there's something else in this circuit that may be messing this up. Unless this is, well, if it was shorted, it would have drawn the voltage all the way down. So it's not that these are shorted or anything. It's showing continuity, but we didn't have any voltage. 0.2. It's all over the place a little bit. It would have continuity because it's going to have continuity through all these other filaments. So it shouldn't matter which pin I go on. Let's try this wire. It shows 5.8 ohms. 6, 5.9, 5.7. Let me take a closer look at these and see if I can figure out if they're broken or something. This one actually doesn't seem too hot to begin with. Let me take a closer look at these because these readings aren't quite adding up here. There must be something else throwing this off. One of these should be open or high resistance. Then it must connect to 0.3. Also 0.3. This one 5.5, so that's a little bit higher. 6.5. So maybe this wire is a bit messed up. Even a little bit of resistance could have an effect here because I think all these tubes, each one draws like an amp or an amp and a half or something. So with all these tubes running, the draw on these wires is over 10 amps. So even like a 6 point something ohm resistance at that current level would have a noticeable effect. So let me do some more checking on these wires and I'll probably just end up replacing both of them and we'll go from there. Okay, so I think part of my issue was that I had mixed up a green and a blue wire since you can't really tell the colors on them anymore. But I still replaced that one that had the deterioration, so should be right now. We'll plug it in and see what happens this time. Turn off the lights for tube glowing effect. You can even see the tubes with the sunlight. Turn that on. And let's see what this time. Okay, so now let's lit up again. Now I can see them glowing. And I can see that one glowing. Okay, so the B plus now. So around 216, 217. I think it was a little bit higher before, but maybe not. Whereas the tubes are not quite be conducting yet. Usually they start glowing before they start conducting. Right, well, that one, yeah, on the end is glowing. So, let's still gonna say on 217. Anyway, let's check for DC bias on the speaker. Let's connect these. So I can sure if my probes will fit in these posts or not. Looks like they will. And we have, well, that's not exactly confidence inspiring. 152 DC volts on the speaker. Guess I'm gonna have to check that out. That doesn't seem right. Yeah, so they're disconnected. So they're connected. 152 volts. Yeah, I don't want to blow up my speaker with that. There should be nothing there because that should be capacitor isolated. So I guess that capacitor might have either shorted or gone leaky. So I'll have to take a look at that. Maybe play with a different capacitor. I think it's a 0.5, so I should have a replacement for that. So I guess we'll have to do that. And we'll just check the V plus one more time because for sure these tubes will be conducting by now. It's still 218, so. Alright, let's turn this off. We'll change that capacitor out. Actually, that capacitor lives in this block, so I'll just cut it out of circuit and put a new one in. And hopefully then we can try this one more time, and if we don't get any DC on the speaker, we will plug the speaker in. Okay, so I've replaced that capacitor with a 0.05. One thing I did realize actually is that the B plus I've been testing is the B plus only for the output tube, so that will be higher than the other B plus. And the ground that I'm connected to is not the cathode ground for the tube, it's like the base ground. So that's not taking into account any, like that's not what the tubes are actually running at. That's just like the maximum, basically the maximum voltage of the radio. So like this tube isn't actually seeing all 216 volts. This is just the bottom of the biasing network. So anyway, what we can do is we can switch from this one to this one. I think this one is the main B plus for the rest of the tube. So let's just, we can see what that voltage comes up to. Anyway, got this connected back up. Let's see what happens this time. Turn out the lights. Violet light comes on. See the tube lighting up already. So we're at 215, 216 there. What about right here? Here we are, oh, it's even higher, 228. I'm surprised by that actually. Thought that would be a little bit lower than the other B plus, but look at the schematic here. You can see that this first connection is after the output choke to the power tube. It focuses. And then the second connection, okay, is the B plus only for the detector tube, looks like. And then this third connection must be the B plus for the rest of them. So let's check that one. Just see what we... There we've got 202. So that one's lower. There's the B plus for the rest of the tubes, so that makes more sense. Anyway, we can check now, see what our bias device is here. We now have, yeah, so now it's just charging that capacitor, so I'd say that has resolved that issue. So we can try, I can try plugging the speaker in while it's on, but I'm not going to do that. I'm just going to turn it off. Thank you for my light going off. And we'll turn this off and we will get the speaker. Okay, the speaker has entered. This is a RCA 100A speaker. I think this is a high impedance speaker. I think the impedance of this is around like 1.2 kilo ohms or something. I can explain why you need a high impedance speaker for this after we try it out. But let's plug it back in. Oops. I got my B plus meter hooked back up on the main B plus for all the tubes. So got some sound. I think I have the volume all the way down, so I don't expect to hear anything at first, if there's anything to hear. I don't hear anything at all, actually. Tuning a little bit. Volume up. I did check this volume control. It is low. Yep, we're not getting any sound whatsoever.
And you know what? It is right
That's
down the
something.
middle. Democrat women who disagree with me 100%, Republican women. It's very interesting what could happen. But your vote's taken away. Zero.
Taken away by
These radios are usually pretty good performers. These Radiola 60 and 66. So it could have been that the oscillator hadn't started yet, and just at that moment it kicked in. So I'm not getting anything up here. Oh, there's something.
on the lawn. Sit down. What can I do for you? Okay. Tree.
There's just some noise there.
So it'll be an exciting second half coming up in Houston. With our free on.
Oh, but this has no ADC, so louder stations are gonna blow you away, while quieter ones you gotta turn it up for.
Who's ready to make love? Right now, single people are at naked.
Based on
It's obviously a louder one.
not a war of Iraq, not the war in Afghanistan, not a potential war with Iran.
The pre-planned arrangements and burial insurance. We have the experience and
Now this volume control is not a logarithmic one, so usually volume controls are logarithmic potentiometers, so that as you turn them, the volume increases by the same amount all the way across the control to your ears, because your ears are the perceived intensity is a logarithmic scale. So, like in order for something to sound twice as loud, you actually have to multiply the power, the actual output power of that by 10. So on these linear controls, at the very beginning, it all sounds like the volume changes quite a bit, and then towards the end, you won't notice much change at all because it's varying the power linearly instead of logarithmically, which is how you perceive intensity. So let's pick up a station here.
Attorney without worrying about.
You'll see it goes away there.
Legal Shield Associates, Otley Homes at 480-695-6436.
The language will actually pretty a little bit flaky.
Plans and small business plans also. Once again,
I
contact
have to
Otley
see if I
Homes,
can
your
clean that
independent
up.
associate for Legal Shield at 480-695. Boston Fountain Missionary Baptist Church.
You'll see it comes up.
Family Values
You're
Radio
like,
with you wherever you go.
it's not like an even increase all the way across the control.
On your Alexa, TuneIn, iHeart, and on.
Well, they do. If you're behind.
Music? Spanish.
The more that you get.
And you give anything, it's between you and God. But the point is, if you were enslaved, literally enslaved.
If you're living with diabetes and using insulin, you know the pain of pricking. A continuous glucose monitor, or CGM, you can reduce the pain of pricking your finger.
Painless. No more pricking my finger. No finger pricks.
Convenience. They delivered it free and they took care of all the paperwork.
Okay, so I'm going to call that very successful. You see our B plus there is having around 202. So let me show you why a high impedance speaker is required. Take a second look at the schematic here. So the way that this is set up, normally in your output state, which is here, let me turn this. Okay. So normally in the output stage, you have an output transformer connected in series between with the B plus and the plate. So the B plus goes through the output transformer then to the plate of the power tube. If you notice here, what we have, this is the B plus over here, we have a output choke, which is just a coil, and that goes straight into the plate, and then the loudspeaker output is picked off from the plate side of the output choke through the 5 microfarad or 0.5 megafarad capacitor, and the other side goes to ground. So this coil here, you can see it has an iron core. This is a high impedance coil, which is necessary because the tube has high impedance. If this was a low impedance coil, you would hardly get any voltage variation here, and you would basically, like this tube would be basically useless. It would be not really be amplifying or not really driving anything. So you put a high impedance thing here, which is basically equivalent to the high impedance winding, primary winding of your output transformer, and then by connecting a high impedance speaker from this side to ground, that's how you get your output. If you had a low impedance speaker here, again, because the tube is such high impedance, you'd basically get, very little current through the voice coil, because this tube is such high impedance and that's such a low impedance, your impedance matching would be way off, and you would hardly get any sound out of the speaker. But by having a high impedance speaker connected across here, similar impedance to the tube, then you get your audio. So a lot of radios at the time, around this time, they started advertising dynamic speakers. And a dynamic speaker is the speaker that uses a regular voice coil with the output transformer. And I believe the reason why they call those dynamic speakers is because in this style, the high impedance one, the coil isn't a voice coil. It's a big, huge coil, kind of like a U-shaped magnet, and then the cone is attached to a piece of metal that sits in between the ends of that U-shaped magnet with the coil wrapped around it. So the coil itself is stationary, and it drives a piece of metal, which through leverage drives the cone. In a dynamic speaker, the voice coil is attached directly to the cone and moves with the cone. So I believe they call it dynamic speaker because the voice coil is moving with the cone, versus a speaker like this where the coil is static. I'm not sure if that's correct, but that makes sense to me. I'd imagine that's why they called it that. Anyway, so that is the basis for this. The Radiola 62 and, well, at least the 62, which was basically the same radio except it had the dynamic speaker, had this basically the exact same setup, and then just connected the primary of the output transformer across here. So they still used the output choke and everything, but then just instead of having a high impedance speaker, connected the high impedance primary of the output transformer where the high impedance speaker would go, and then use that to drive the voice coil via the low impedance secondary. So I hope that makes sense as to why we have a high impedance speaker here. Only the very, very, very high-end radios at the time had the dynamic speaker. I think the first one that had it was the Radiola 32, which was like super top of the line. I don't know how any of those were sold in 1927. And then in 28, they came out with the 62, which is basically the same radio as this, but with the dynamic speaker. And it actually had a separate power supply just to power the voice coil. So that brings me back to my plans for this radio. I just have the chassis, I don't have the cabinet or anything, so I'm probably going to build a cabinet or something for this chassis. And I was thinking about perhaps acquiring a dynamic speaker that I could use here with an output transformer. So I'm going to be on the lookout for that. Until I get that, I think this project's going to be set off to the side. We know we have a good working radio. Sounds pretty good, don't hear any distortion. Is receiving very well, even with just the piece of wire antenna kind of sticking out of the chassis. I don't have any extra antenna attached to this, and no ground attached, so this is definitely, seems to me to be a good radio. Definitely something we can build something with. So I'm going to be on the lookout for a speaker that I can use here. If I have to buy an output transformer and a speaker separately, maybe I'll do that. If I can get a Radiola 66 or 62 speaker, I think that would be an excellent fit here because, well, at least on the 62 speaker, the output transformer comes mounted directly onto the speaker, so I wouldn't have to find an output transformer for that. With the 62, I would probably have to find the special 62 power supply, but for now, I think this is going to be about it. Maybe we'll do one more channel sweep and just see what we can pick up. But definitely satisfied with this so far, and I think we can move forward and look for some special speaker to put there. See if we can find my music station. Turn this back up a bit. That was loud. That sounds like my music station right there, actually. It's a little bit weaker. And this knob is not the right knob, I just stole this from something else. See if we can tune this a little bit better. One of the problems is these tuning capacitors get so stiff. This one's not. So not interference, I think there's just some interference at this particular frequency because all my radios seem to pick up at least some level of interference on the station that isn't always present on other stations. Well, as you can see, this station is definitely a much weaker station than some of the other ones that we got that were blasting us away. Actually harder to adjust it this way.
Prayer is something from over.
This is a much louder one.
But it looks awful once it's painted on the wall. And if it's a strong enough color, you then have to paint a new primer coat over.
Different fluctuations in hormones. It seems like there are a lot of supplements that are discussed and promoted for you to take so you can naturally
Everything
change
sounds
these
nice and clear to me.
over the counter without really having any idea of what those values typically are or where it's your base.
And you get 2% if you go to a 30-year bond. That is the only 2% bond.
30 years, wow.
Don't expect interest rates to come back up for at least another 5 years.
So maybe not perfect for listening to a music station, although that might improve if I put an antenna on. Let's do that actually. I have an antenna here somewhere I can use. Antenna is connected. Let's tune back up to where that is and see if it makes any difference. Oh, and increase the intensity, and I have the volume control much lower than I had before for this volume level, but there's still some interference there. There's just something on this frequency, I think. Let's disconnect the antenna now. So the intensity drops. It might be a little bit clear without the antenna. Anyway, this is definitely a good radio. I can't complain about this particular station because, like I said, all my radios get interference here. So I think that's going to be about it for this video. We've got a nice, good working radio here. Let's see if I That one's getting warm, that's the power transformer. That one's cold, that's the filter choke. This one is cold, that's the capacitor and output choke block. So I'm not going to worry about the wax paper capacitors for the B+. Usually those stay pretty good. In these old radios, I have a Radiola 17 that still has good wax B+ filter capacitors. And I don't feel this box really getting warm at all, so I don't think that they are leaky. And if they are, there's not any amount, not enough to generate any heat in this box anyway. So, and this box is right next to the rectifier tube, so that's blasting heat on it. But anyway, that's going to be about it for now. I'm very satisfied with this radio, and we'll see what we can do with this next. Thank you for watching.